Stephen, I've just started the recording. Thank you so much for sharing today, and we're really excited about it. Thank you.
Okay. I am so glad to see all of you. It's like a reunion. This is so great. Thank you so much for being here. Hope everyone's doing well. I'm gonna try and keep it like not like a conversation with people who I knew during a like really difficult, tumultuous time, and instead just keep it like a conversation that is a presentation. It's a presentation, but it's good to see you guys. Okay, so we're gonna talk about data and computer science. So really what it comes down to is that I do a lot of work. I'm a part of STEM programs. Oh, let me go to the next slide to explain why I'm saying this. Okay, so I am a part of STEM programs here at the San Joaquin County Office of Ed. So my mind, while it is often on computer science, is on science, STEM. But we do a lot of work. I think there's really the strongest chance for learning and opportunities for growth and new projects when we have an intersection between two subjects. So I was doing some work with the California science educators, and we were looking at, what's the role of computer science to science educators? And data is this really great intersection between both computer science and science. So I'm just going to start off by showing you. We're going to start off talking with standards. It's boring to talk about standards. I feel bad, but it seems like something that I'm supposed to do, like, eating your vegetables first, or this message is brought to you by. I like just going ahead, starting with standards because, why are we bothering with this? Well, because it ties into stuff we need to talk about anyway. So we're going to look at both the, because I'm hearing Callie, the California computer science standards. It doesn't matter. They are made off of national standards, so they're very close to wherever you are. There's probably something that's like this. And the next generation science standards, again, I went with the California ones, but there's like a couple of, what are they called? Limits. They're slightly off of the national, but it's almost exactly whatever you're going to see anywhere in the country where the NGSS is being used. So let's look at first NGSS. All right. So if we look over here at science and engineering practices, you'll remember that the NGSS, if you are a science teacher, the NGSS is three-dimensional. And what they mean by that is all the kids have their performance expectation. I went with, and kind of, we're going to use this as a theme throughout this very short talk, the motion, gathering data from the motion of a little robot, okay? So there's a standard here, high school physical science 2-1, and what's talking about is Newton's second law, force. We're talking about force and acceleration. Y'all have heard of that. Well, every performance expectation the kids work on is supposed to have three aspects that you deal with in teaching them. One, the disciplinary core idea, which is like the facts. Hey, Newton's second law accurately predicts the motion of objects. Fine. But the students are supposed to also thinking about these cross-cutting concepts that are throughout science. Cause and effect. I love physics because there's very clear cause and effect. I push on this, it moves. So you're supposed to be thinking about, okay, we've got a cause, we've got an effect. And then with this one, we're supposed to be looking at data and analysis, or, well, in NGSS, we call it analyzing and interpreting data. Whole point is we have all of these values that we're going to gather, and we're going to look at them and go, oh, well, that's what this means. And students need to be able to do that if they are. But by the way, there was a tweet, there was a message. I almost said it's a tweet. It's not a tweet. It's a message in the chat asking if I taught in Berkeley. In college, I taught at this. At the college I went to, there were these little student courses called Cal. I can't remember what they were called, but they were student taught classes. So I was in college. I taught at Cal. But it was just like a free, not even an extension. they were, if you were short on units and you were a student, you could teach a class and people would take the class. So that was that. I got to do that for fun. But I taught in the Bay Area before I came out here to the County Office of Ed, like as an actual teacher. So data, we're looking at data in science. Oh, my tab just closed. That's weird. No problem, I can fix that. All right, tab reopened. And we're back. All right. Let's look at the California Computer Science Standards. So right here, I wanted to point out that the California Computer Science Standards have 5 different categories, and those 5 different categories are computer systems. Computers, like all computation, occurs on a physical system. Even if we're thinking about our brains, that's a physical system. You know, we work in base 10 because we have 10 fingers. Like all computation occurs on something physical. So computer systems is a part of the computer science standards. Algorithms and programming, just the actual writing code. Impacts of computing, which is really important because we end up with problems if no one thinks about the impact of what they're creating. And networks in the internet. Computers are not nearly as powerful if we don't have networks. We're all talking all over the place, all over the world because of networks. But the other one there is data and analysis. So I wanted to look here at one of the standards, 912 DA10, create data visualizations to help others better understand real-world phenomena. So it is computer science if we are helping kids to use computers to create a visualization of their data. Okay, enough of standards. Let's move from that really quickly. But just saying that is how the two of them overlap. All right, so I want to talk for a second about AppScript. Okay, so I was totally surprised this happened recently. They moved where AppScript is inside of a Google Doc. It moved from tools. It was in tools, and now it's in extensions. It's the same thing. It is the code that is at, it's behind all of our Google tools that we love so much. So I am bringing up a Google Sheet. I made a really simple one, the one that you guys see right there. I'm going to share the tab. Boom. All right. So here I have a bunch of entries. Make sure this is showing up to everyone. It is good. I have a bunch of entries. Let's assume that these are the speeds of this object that's moving along. It's kind of a weird jump there, but whatever. And what we have here is a button. When I click the button, oh, it shows me the sum of all of those entries. I'm going to close that. And I'm going to go to extensions now, because it's different, and say AppScript. And right here, here's our editor. And this is the code that was able to take all of those entries and calculate their sum. Now, let's think. What would be more interesting? Let's say that instead of calculating the sum of all of these entries, I want the average. So I'm going to take this code here. I'm going to copy it, paste it below. Try that again. Delete. Okay, Control C, Control V. There we go. Okay, and what I want it to do, I'm going to say show tab. All right, this line here grabs the user interface. That's how I'm going to be able to pop up the screen. Right here, I'm taking the sum of all of these entries. So right here, for, it's a for loop. It's going to look for items 0 through 11. So there's 12 of them. It's just going to go through in a loop, take each of them, add it on. And I'm just sending this to my log just to, you know, keep track. Helps me with debugging. But at the end, I'm going to do one more thing. I'm going to say my sum divided by, because there's 12 of them, I'm just going to say divide by 12. Okay. Then I'm changing what it's going to pop up. This is the average, so this is the sum. And then at my sum, instead of that, I'm going to say my bar, my av equals my sum divided by 12. All right, it says that I have not made a bug. We don't know. We'll find out soon. Okay, so I'm going back here to my spreadsheet, sharing this tab. There's the spreadsheet. Now, you remember I was able to just click on this button and up came a dialog. I'm going to right click on this and I'm going to duplicate it. So right click, Control C, Control V. Not quite go like I want. Control C, Control V. Let's go the long way. Paste. It does not want me to paste. That's okay. I'm just going to draw it. So I'm going to drawing. I'm going to make a rectangle. For these buttons, I really like using a gradient. Just going to type in average. That's kind of faint, so it's not going to show up too well. So what I'm going to do is I'm going to make it a little bit larger. That'll be good enough. All right. So I've made a drawing in my spreadsheet. And I'm going to make it a little bit smaller. And I probably should have gone with a different color. So we had multiple colors, but whatever. And I'm going to assign a script. Now, the script that we wrote was called show ab. So assign script, show av, say OK. So when I click it, pops up. This is the average 16.833. Okay. I can write anything in AppScript, tie it to a drawing, and it becomes a button on my spreadsheet. This is nice because what I can do is I can give the students you know, a worksheet. I can have different colors where they're going to fill in. I can explain to them, because there's lots of space on a spreadsheet, almost infinite space. Explain to them the calculations that they need to do. I can give them a button to help them do some of the calculations. I can essentially make a spreadsheet that is an app to help the students with their science. While we didn't go ahead and make those data visualizations that we were talking about earlier, it's not like it would be hard to do that too. So we can take the kids through the process of looking at this data, you know, gathering the data, looking at the data. Now, I still have promised in the remaining 6 minutes a little bit more. I did want to talk about, let me jump to here, Collab. I don't know how many of the viewers, I'm trying to keep track of both the viewers who are here and viewers who might see video recording later. Some of you might have used Collab before. Collab is what we call a Jupyter notebook. It is awesome. While it doesn't use AppScript, it uses mostly Python. And it's a great way for students to be able to make their calculations transparent to others. So I'm just going to go ahead and show you a screenshot here. I don't like the screenshot that much. But you'll see here, I've made a variable speeds, and I've put the same array, the same set of values into this array that I created, 3, 4, 5, 6, 7, 8, blah, 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 blah. And then I have my calculations, but they're done in Python. So it says here, average equals sum of speeds, my variable, my array, divided by the length of speeds, my array. And then I just tell it print average, the variable I created, and oh, there's the same calculation right there. I really like the idea of using using Collab or a Jupyter Notebook as opposed to a spreadsheet, and here's why. It is clear what calculations someone did in order to get to where they are. I sometimes feel like, or I often feel like, a spreadsheet is very opaque, right? If I want to see what calculations someone did, I need to click inside of one of the cells, and I don't know which cells had the calculation. It can be garbage. I mean, like, they're valuable. I love spreadsheets, but it can seem like a mess that you can't really understand where it came from. Not so with the Collab. I just read right through it. I'm also going to point out there are 2 different types of cells. So I'm just going to bring up Collab really, really fast. I'm only allowing it 1 minute. Okay, file, open. And sharing the tab. All right, here we go. So this is the Collab that I was showing you earlier. Notice I can add in more code or I can add in text. The text is nice. It uses something called markup. It's a superset of HTML. So I could say something like markup is awesome. E. All right, so I've written my markup. You notice that showing me what it'll look like off to the side. I'm gonna go ahead and get rid of this. Delete. And when I click out or into something else, it just shows up kind of like a web page above what I am calculating. Whereas down here, if I were to say I just want to add in more code, I could say something like you did not see me put a semicolon at the end of a line of Python. Yikes. I've just been switching between languages. All right, there we go. So we can have calculations going along with explanations of the calculations. So a Google Colab can be really useful for allowing students to do their calculations along with instructions maybe that you have in HTML written very clearly for them, and then they can do the calculations below. So it's a great tool to help students work. All right. The only other thing that I wanted to share with you guys in my remaining minute is we can gather data from some cool places. This video, which we totally can't see any of it in the minute that we have, is me gathering wave data at Asilomar and throwing it into a spreadsheet. We have a bunch of videos at our county office. We have a resource website, sjcostem.net. And all of the videos that I made for my Google Innovator project being mentored by both Clay and Tom, who you can see above me on the screen. Last year, there's lots of videos there to walk you through both app script. Let me see. We have teacher blocks, which is the little bit of a language that I made for block-based coding of app script, and just regular app script. And we're at 340. So that's it.
Thank you so much, Stephen. I've dropped the information for the next session in the chat. Stephen, appreciate your sharing, and I will stop the recording. That was great.
Thank you. Thank you all. Bye.